Welcome, everyone. Welcome. Good morning, good afternoon, good evening. I'm Sonia Moise. I'm a senior security advocate at Snyk, and I'm going to be taking you through today's session. Stranger danger, your JavaScript attack just got bigger. And today I'm also joined by Patch here, so he's going to help us today. So what are we going to talk about today? So at first, we're going to have a look at the current state of open source software. What are the hot topics? We're going to also have a look at the iceberg, and you might be like this little emoji saying, what is she talking about? But I'll explain. And then we're going to have a live hacking session with a few vulnerabilities. Thanks, Micah, for sharing. And yeah, we're going to be helped by Patch today. He's going to help us remediate a few vulnerabilities, and we're going to have some learnings along the way. So let's start. So first of all, let's have a look at the current state of open source security. So we know that organizations of all sizes are heavily reliant on software because much of that software supply chain consists of a lot of different open source software components. And OSS has cybersecurity implication because this is an interesting and attractive entry point for people and organizations interested in theft, disruption, or exploitation for economic or political gain. Thus, the attack surface is changing for what we've been knowing. And we've seen that defects in small libraries can cause systemic risks, and we've seen it last year with the incident with Log4Shell. So why application security is important? We know that vulnerabilities can originate from something as simple as a config error or using software component that contains a known vulnerability, which is why maintaining and improving application security is so important for businesses. One recent study revealed that out of 85,000 applications that were analyzed, 83% contain at least one security flaw. And of these, 20% has severe vulnerability. While not all of these vulnerabilities necessarily present a major risk, hackers continue to refine their attacks by using ingenious workarounds to penetrate software. And we have organizations such as OWASP, which stands for Open Web Application Security Project, that tracks vulnerabilities found and provide a list that developers and security teams can use as a starting point for their application security program. The most recent OWASP Top 10 list was released in 2021, last year, and included broken access control, injection attacks, security misconfigurations, and others. So let's have a look at some open source software attacks. The first one is typo squatting attacks. Typo squatting attacks takes place usually when bad actors push malicious packages to registry with the hope of tricking users into installing them. This is really similar to website phishing attacks that exploit typos made by individuals who may accidentally typing a wrong address. Here we have an example with the package React with a typo. And in that case, you will not install React, but a malicious package that has a completely different end goal. Another example is malicious packages, which inject malicious code into a software product in order to compromise dependent systems further down the chain. And in this example, we're having a package called Fall Guys, and usually the malicious actor will try to surf on trends. So in that case, the game has been quite popular during the pandemic, and users might think that by downloading this package, they will get an advantage in the game. So obviously, Fall Guys here is a malicious package that contains malicious code that attempts to read local sensitive files and exfiltrate information through a Discord webhook. So this was the entry point in that case. And the code attempted to access specific paths available on Windows systems. It was looking at the local storage level. One last example is compromising maintainers, where malicious actors will use social engineering methods to gain access to open source projects. So here we had an instance with the event stream package where the malicious actor did social engineering the maintainer. So at first, he went through all of the issues of the project and have a look if he could potentially contribute. And he pushed some cosmetic changes at first to build up the trust with the maintainer. So he changed some files like CSS files or the README files. And once he got more permissions, he pushed his malicious payload into the code base. And it was targeting a Bitcoin wallet in that case. So his modus operandi was interesting in going through all of the issues and see if he can contribute to it, be trusted by the maintainer, and then push his code. This is known as a supply chain attack. also called third-party attack. So it usually occurs when someone infiltrates your systems through an outside partner or provider with access to your systems and data. It doesn't affect only JavaScript packages. This is an issue for all ecosystems. We had a recent example with Log4Shell last year within the Java community with the vulnerability in the open source Apache Log4Loggins library, where one of the Log4j exploits allow remote code execution on the servers, running vulnerable applications without requiring authentication. And that has earned the vulnerability a severity rating of 10 on the CVSS scale, which stands for the Common Vulnerability Scoring System. So supply chain attacks are attractive to hackers because when commonly used softwares or packages are compromised, the attackers could potentially gain access to all of the enterprises that use that software. So let's try to understand how this is possible. And first of all, let's say hi to the iceberg. So if you're still confused by that statement, let me explain to you. That's the iceberg. And let's start at the tip of the iceberg. So our starting point is our code. This is the proprietary code that we write in an organization. Does it bring security vulnerabilities into our code base? Maybe, maybe not. In that example, we're having a database injection because we're not sanitizing the user input. So here we have a function signature of an Express application with a function which has a request, a response, and an X callback. It's trying to call the user table or collection, so which means that there's a database behind the scene, and it's also doing a login, so it's looking for the username and the password. So what are the vulnerabilities here? What can go wrong? So as I said, this is an example of a database injection, and more specifically, a NoSQL injection. So applications built with Express will have body parser to parse the JSON object, and it takes whatever you send to you and convert it to a JavaScript object. So if the request has a username and a password, this is going to be part of the JavaScript object. And if you're using MongoDB and add the $sign greater than as a key and an empty string as a value, the JavaScript object will tell MongoDB to do a greater than match to filter all the results. So if you send a request with admin as a username and this object to perform a NoSQL injection in this piece of code, then yeah, you'll be logged in as an admin, basically. So this shows the importance of sanitizing inputs and to handle this as soon as possible before it's stored into your database. So we're starting with our codes where potentially we can have security vulnerabilities. This is another example with a piece of code to import dependencies. And we're going to come back to that specific package marked, which is used to implement Markdown within your code base. But this is a nice segue to the layer below the application code on the iceberg. Open source code layer. So if we think about how many lines of code we write ourselves versus the number of packages we import to cut down the time we spend coding, we don't want to reinvent the wheel. And this is totally understandable. Why would we want to waste some time to rewrite something that might probably exist as a package in our ecosystem? And that's what we have here with the marked package. And we can see also a lot of different NPM packages around within our code base. But we're not bringing several packages into our code base, increasing the attack surface and introducing new risks. And we do have a few questions with that. So are we aware of all the packages that we have? Are we aware of all the dependencies and sub-dependencies? Do we have a good understanding of indirect and transitive dependencies? Do we have tools that help you to having that level of understanding and visibility? As well, most importantly, what are the risks when you bring a dependency into your code base? I know that's a lot of questions, but let's see some numbers around that. So the average number of outstanding critical vulnerabilities in an application is around 5, and obviously this will depend on the programming language that you're using. The average top-level dependencies per project is around 80, but the most concerning one is the last one. The average number of days it takes to fix a vulnerability is around 100 days. So enough chatting for now, and let's move on to hacking an application and understand more about how dependencies can impact your application and introduce vulnerabilities that you were not aware of. So I'll be using a few applications from the Sneak Labs organization on GitHub. First of all, I'm going to use the Node.js goof, and this is what it looks like when you actually git clone and run it. So as you can see, this is patch to lists. So yeah, we can say hi to patch. Yeah, you can see this is just like the regular to list. but we're gonna put our attacker's hats, and we're gonna think about how we could potentially tamper with this application. There's a few entry points that might be interesting for an attacker. So let's have a look first at this URL. So as you can see here, now I'm serving the application on my local machine, so that's why you have localhost. But imagine this application is hosted on the server. Well, let's have a think on how we could potentially tamper with this URL to have, I don't know, like credential, password, sensitive files. Let's think about it. So let me start first by having a look with the public folder. So what I'm trying here to do is actually trying to access folders or files that could potentially reveal sensitive information. And by just typing the /public folder, I actually have access to a few. So let's have a look. Have CSS file, JavaScript files, robots.txt. Okay, that's a good entry point. That's a good starting point for a potential attacker. So maybe by keep doing this, we can traverse directory to try to find sensitive info. So let's try with the .. Oh, okay, we're back to the main page. What I was doing here with the .. command is to check the parent directory of the current directory I'm in. So in that case, I wanted to check the /public parent directory. But it goes back to the front page. Okay, but I'm a smart hacker, so I'm going to try to use URL encoding. So URL encoding is basically replacing unsafe ASCII characters with a percent followed by 2 hexadecimal digits. So what I want to encode is the .. So in our case, the dot will be replaced with the percent to E and the slash with the percent to F. So let's try this. So I'm going to go back to the public folder and add this. Oh, interesting. Okay. So I did actually manage to get up from one folder from the public folder. So let's have a look what we have here. Deploy Heroku, Markdown. Okay. There's some indications. Interesting. Let's have a look at the other one, Docker Compose. Ooh, what are we having here? Credentials. Interesting. Okay. What else? Let's have a look at the Dockerfile. Okay. Let's see if we can continue by going up and see if we can have access to other folders. Yes, we can. So as I mentioned, I'm hosting the this application on my machine. So obviously you'll see the folders from the architecture of my device here. But yeah, and if I keep doing this, I have access to the etc folder, binaries. Obviously, I'm not going to click on the etc. I don't want to reveal sensitive info live, but you get the idea. So what is going on here? Because this is not great. So this application, as you can see, this is a full-fledged Express application. We're using a few packages. As you can see, there's quite a list. But for the one that we're interested in is that one, the st, which is basically serving static files. So we've implemented this this package because we didn't want to rewrite the whole functionality because it already exists. So we thought it would be quite convenient to implement it. And we're instantiating it here. Okay, so what is going wrong with this package? Let's ask some help from Patch. So first of all, we'll need to go on the marketplace. And I'm using VS Code here. So if you type snick and you select the first one, the snick security code and open source dependencies, you'll be able to install it. You'll need to reload your IDE to take into account. And then you'll have this little patch icon here. So the first time you won't see the all of your vulnerabilities from the your project. You'll see patch icon asking you to authenticate. So if you have a sneak account, you can just link it and then start and trigger your first scan. So as you can see, there's a few vulnerabilities here. Okay, so let's see if we are going back to the package.json file and go to the st package here. You can see there's like 2 vulnerabilities here. There's like some red lines here. And if you hover on the, click on the yellow light bulb, show the most severe vulnerability. Boom, we're having the directory traversal vulnerability. Okay, let's have a look at this one. So here, Patch is telling us that this is the directory traversal. Cool. So we're having a few metadata around this vulnerability. And we also have a link to Sneak Learn. So if you want to learn more about this vulnerability, you can actually have a look on Sneak Learn. And you can filter by ecosystem. Here I've selected JavaScript. And if I do traversal, yeah, directory traversal, you will have access to like a one-pager lesson, and it's like a hands-on labs where you can actually try the vulnerability and everything in sandbox within your browser. So it's quite interesting if you want to learn more about those vulnerabilities. As you can see, I'm just going to remove this. There's a few like XSS, open redirect, server-side request forgeries. It's quite interesting. Going back to the vulnerability. So what else patch is telling us? So this has been introduced through this version. Okay, and it's fixed with this version. Okay, and we do have a proof of concept. Let's see. So the versions prior to this version didn't properly prevent path reversal, and we've seen that. So literal dots in the path were resolved out, but URL encoded dots were not. Thus, a request like the one that I've actually put would leak sensitive files and data from the server. Okay, so what else? This is explaining also what is a directory traversal attack, also known as path reversal, which aims to access files and directories that are stored outside the intended folder. So by manipulating the // sequence and its variation, so I've been URL encoding this, which falls under the variations, or by using absolute file paths, it may be possible to access arbitrary files and directory stores on file system. And in our case, this is information disclosure. Cool. So now that we have a little bit more context, we want to fix this because obviously we don't want this into our code base. So going back to the package JSON, what I'm going to do here is change the package version. I'm going to stop the server and do an npm install here. So basically here you see that we're having the to-do list application, and because we didn't want to implement ourselves this feature, we decided to implement a components. This actually brought us that vulnerability with this specific version of the package. Let me just restore the server. And going back to the application, if I refresh, can I get access to that endpoint anymore? Which is great news because I didn't want people to have access to my etc folders and see all my CRES and password and sensitive data, which is good news. Another way to see if it's fixed, going back to the little left sidebar when you click on patch, just going to scroll down and you can see there's like 2 vulnerabilities here, including directory traversal. So if I trigger another scan, that one should be gone because it has been fixed. So it takes a few seconds to scan the projects by querying the database and coming back with the results. And yeah, there's only one for ST. You can see the open redirect. The other one is gone. Cool. So we did fix one vulnerability. Yeah. Let's have a look at the other entry point. So the other one, the obvious in the middle here, is this inputs. So here, and seeing this input, I'm going to try to do some sort of injection, obviously. So we're going to try and see what we could use. So this like regular one, let's see if I can use Markdown here. Yeah, okay, interesting. So let's see if I can use links then. Okay. So if I click on the link, this I'm redirected to the Snake website. Okay, makes sense. Let me try with the usual scripts, the alert tag. That's not working. Okay. Also, that means that's might be a little bit of sensation in place. Okay. Let's be a like smart hacker and let's build up on the link. So here what I'm doing is, because we've seen there's some sort of sensation in place, we're still not sure what was going on in the back end. It seems to do some filtering. So let's try with the JavaScript colon protocol. Okay. That's a little bit of feedback that we're having here. That's a good starting point for an attacker, because usually and trying different payloads and building up on those payloads and crafting better ones. So, okay. We can see here that it's doing some sort of filtering around the value JavaScript colon, which is potentially a vector of attacks. So let's try with this payload. I'm just going to zoom a little bit over. Cool. So here what I'm doing is using HTML entities. So HTML entities is basically replacing the colon with, if I can find it, this and the closing parenthesis, which is 41 here. Cool. So here you can see the JavaScript colon, which I'm replacing it here, and the closing parenthesis here. Okay, let's see if this works. Oh, okay, it's gone. There's also a little bit of feedback that we're having, and potentially for the attacker, it's great feedback. So let's try with something else. I'm adding the this keyword. So here, what we're doing is we're using the JavaScript colon to try to break out of the logic implementing in the backend, and which is blocking us from hacking this application. And we're assuming that the condition must expect exactly the JavaScript colon protocol. But in this case, we're encoding it, and we're adding the this keyword, which is a valid keyword in JavaScript. And you can replace it with window or documents. It will also work in that case. So by combining the HTML entities and the browser permissiveness, this will enable this vulnerability. So let's have a look. Hey, patch alerts. And if I click, I get patch here. Okay, let me try with something else. So this application doesn't have a cookie, but I'm doing with document location, not the documents.cookie. But if I click here, I have the location. Cool. So here for an attacker, that's the first step when testing an application to see if there's any entry point to craft a better payload essay. So here we're having an example of stored XSS because the payload is saved in the database, and if I refresh, I can still see the this payload. And you might say this is great, Sonia, but this is just an alert. Right, but if you think of a social media application where you have user profiles, visitors could potentially click on the link on the profile, and the data would be sent to the attacker servers containing sensitive information, like, for example, session cookies. So let's see what is going on in the code. So going back to the app.js file, here we know that we've been using marked. Just gonna zoom in a little bit more here. We've been using marked for implementing the markdown within the code base, and we're instantiating it here. So you can see we've done a little bit of due diligence. We've been through documentation, and we wanted to implement some installation. So we did set the options, send size, flag as enable, set to true. But this is not enough, apparently, because we could bypass it. So let's ask patch help. In that case, going back to the package.json and hover over the marked package here. So if I click on the yellow light bulb, I'm going to close this too. Cool. So here, patch is telling us that we're having process scripting vulnerability. Okay, so a little bit of metadata. We also have the link to SneakLearn if you want to learn more and have a hands-on labs around that specific vulnerability. And it's giving us a little bit more info around when it was introduced, how we can fix it. So let's have a look. So marked is a low-level compiler for parsing markdown without caching or blocking for long periods of time, and it's giving us a little bit more context around what is going on. So affected versions of this package are vulnerable to XSS. An attacker could bypass its output sensitization, the flag that I've showed, a protection, using the HTML-coded character set. So the attackers can inject JavaScript colon code snippets into the output. So for example, the input that I've showed you earlier will result in whatever payload you put. In that case, this was an alert one being executed when the user clicks on the link. So here we're having a perfect example of process scripting attack. You have a little bit more context around that, and the type of that specific XSS in our case is a sort of one, because when we refresh the page, the payload was still here. Cool. So we don't want this. We want to fix this. So let's go back to the package.json and let's bump the package. Where is it? Here. Cool. So I'm just going to change the version of the package. I'm going to close the server and do another npm install. Whoop. Cool. So here you can see that we've been creating this to-do app, and we've implemented 2 packages. And by implementing those 2 packages among other packages, we've actually implemented a few vulnerabilities. So let me just restart the server, and this should be fixed. Yay! Just going to remove all of these items, and just for the demo, I'm just going to re-enter this input and see if this is really fixed. Yes. Thanks, patch. The 2 vulnerabilities are gone now. Our application is way more secure. Cool. So what did we learn? So first of all, we can use Snyk Advisor to check if a package is secure before implementing it into our code base. So let's have a look at Snyk Advisor. If I can find it here. Cool. So Snyk Advisor is a free online platform where you could look for packages before implementing within your code base, and you can do so for NPM, PyPy, Go, and Docker. So in our case, let's have a look at the ST package. That was the first one that we've fixed. So here you can see it's giving us a little bit more info around the health score, the package health score. That's giving us also a few dimensions: security, popularity, maintenance, and community. And if you're not satisfied with the health score, you can explore similar packages which are doing the same functionality. So it's giving you a little bit more insights, what's going on at the for each version on security sites, the popularity of the package, maintenance, when was the last release, the last commits, and a little bit more info around the community. Cool. Let's have a look at the marked package as well. So the marked package has the perfect score. So obviously, for the purpose of this demo, we used a very old version of the package, which was vulnerable. But yeah, here you can see that's like perfect scoring here. And using the last version is free from any security vulnerability, which is good news. It's quite a popular package. And we can see that on the maintenance, the last release and the last commits quite often, and the community. So here you can just type the name of your package and see those kind of info and insights and metrics, which is quite good. We can use the CLI to check the vulnerabilities as well. I've demonstrated how to do it within the VS code, the IDE with the integration, but you could do the same through your CLI. So let's have a look. So I'm just going to type Snyk test. And this is going to query the vulnerability database, and it should mirror what you have here. It's just like if you're more familiar working on the CLI, you have the exact same outputs. And if you found that there's a little bit too much information here, you can actually filter this with the flag severity threshold. And I'm going to put this equals to high. And in that case, it will only give you the highs and critical. So you should only have the red ones here. And as you can start tackling those before the other one. Cool. You can also have that visibility on the Snyk dashboard if you import your project. So you can monitor your project automatically. If there's any new vulnerabilities introduced in your application, you'll be notified. And by doing so, also this will mirror what you have on the CLI and what you have on the IDE integration. You'll have the same kind of information. You'll have the detailed path and remediation, a little bit of overview to give you context. You'll have the link to the Snyk Learn lesson. And if you click on the screen button to fix this vulnerability, you'll be redirected to this screen where you could actually bulk fix all of your vulnerabilities, or just cherry pick which one you want to fix first. And this will actually raise a PR where it will give you some merge advice. So depending if there's any breaking changes on your pipeline, obviously this will depend on the pipeline and the suite of tests that you have within. So also you have the Snyk Learn lessons where you can actually learn a little bit more about those vulnerabilities. So let's go back to our iceberg. And the third layer is containers. an application needs to be deployed somewhere, so we're using containers and static websites to deploy our projects. So we have different ways to do so. We can use Docker, Versal, Netlify, cloud providers. Now, if we're adding a Dockerfile now in the equation, which has the metadata about our project, this is adding an additional layer within our modern application, because we're running our application as Docker images, and this adds to the complexity of the project and increase the attack surface. So again, Snyk can help you scan your Dockerfile and have that visibility where you can have like the insights on the criticals, highs, medium, and low within your Dockerfile. But let's take a step back and let's see a really basic Dockerfile. So what could go wrong with this Dockerfile? Well, a lot of things. So let's see them. So first of all, when we install packages, common software vulnerability, and I'm going to come back to this ImageMagick because the team behind ImageMagick created a dedicated website called ImageTragic to showcase all of the security vulnerabilities, including remote code execution. And I'm going to demo this in just a couple of minutes. But yeah, just to be aware that there might be some common software vulnerabilities around those. Also, installing dependencies during runtime. We would recommend to use the only production flag to avoid pulling dev dependencies and non-deterministic package install. Also, we're looking at security releases. If we're picking a large image, it might have many vulnerable libraries. So for example, the runtime vulnerability here around Node. Are we looking at security built-in? What are security releases and what is going on around the images in the ecosystem of the images that we're using? So on the Snyk platform, you can see the recommendation for upgrading the base image. So it will show you the current image, and you can compare it with alternative upgrades that you can if you want to choose an image with fewer vulnerabilities. This will obviously depend on your risk appetite and the risk policy that you have within your company. And again, same with Snyk Advisor and some info to help you taking a decision on which Docker image will suit your project. So let me show you this. So if you click on the drop-down and select nodes, Docker, sorry, I'm going to type node here and have a look at the node image. So it's giving you a little bit of info on the stars, the numbers of downloads, and most importantly, you can select the tag that you want, and then it will compare. You can compare it with the other tags, and then you can go from there and see which image you want to implement within your project. Cool. So let's go to the live hacking session for the containers. So first of all, let me set the context. So I'll be using this really fancy application, as you can see. But basically, I'm going to upload an image here to convert it as a Twitter ideal photo size. So by clicking this button, resize, and I should have an image after that. So this is just the flow. But behind the scene, I'm using ImageMagick package. And as I mentioned, the team created this dedicated website where it explained that ImageMagick is a package commonly used by web services to process images, and one of the vulnerabilities can lead to remote code execution, and if you process user submitted images. Okay, so let's have a look here. So the first payload that I'm going to use is this one. So I'm using the API from the ImageMagick package, and here the first payload is just going to create this file. And the second payload that I'm going to upload is to create a reverse shell. Cool. So let me just set the scene first for this remote code execution. So the first one, I'm going to move to the exploits folder, and I'm going to serve. So the first window here, I'm going to spin up a local static server. This is just to serve the netcat package. Just going to minimize this window because we don't need it. Just going to zoom out a little bit so you can see what is going on the three screens. The second one is to actually connect to the Docker container. I'm going to just run who am I here, some roots, okay, and do an ls. So you can see that there's no RC1 JPEG or any file name with RC. So, and the last one, I'm just going to run netcat just to make sure that this is listening. Cool. So going back, yeah, that is fine. Going back to the application, I'm gonna upload the first payload, which is basically I'm gonna create that RC1 JPEG. Gonna resize and image resizing success, but I have a broken image here. Okay, what is going on? Let me go back to here, and if I do LSLA, oh, interesting. Here you can see that I've actually created a new file called RC1. Okay, let me upload the second one. So the second one is basically to create that reverse shell. So I'm gonna upload this one. Click on resize, and it's still hanging. Okay, that's not a good sign usually. Let's go back here and see what is going on. Cool. So you can see there's a lot of new files been created, which is not a great sign. But basically, we're going to have to wait 10 to 20 seconds for the netcat utility here to be downloaded from the local static file server. So it's in this window, but we don't really care about that first one. But this is going to be compiled and executed to then create a reverse shell that will allow me to interact with the local netcat listening prompt. So basically, I'll have a direct connection to the container image. So just going to put HMI here, and it should come back with roots, hopefully. And let's have a look here if there's any new files created. No, this is not a great sign. You can see here there's like some of the reverse shell being created here. So hopefully we'll come back with, yeah, roots. Okay, let me just change the shell here. Just going to improve the shell because this is a little bit going to prettify it. Spell. If I can type it, in dash. Cool. Okay, so who am I? You can see I'm root, but just for, so I'm root. Okay, that's cool. And now I can start navigating on there. I just gonna maximize this one, but basically this is mirroring what you have on the container. So I don't know, like let's go up few followers, and yeah, you can imagine what an attacker, potential attacker, can do. Like now that you have access to Docker information, so I could potentially go on the root folder or the etc, try to find sensitive files and exfiltrate that data and exfiltrate it onto my my server. Cool. So we've also produced cheat sheets around the on the Docker image security best practices, where we recommend to have minimal based images and also to use multi-stage builds for small secure images. So basically, when you're in the during the development phase, you could use larger images because you want to experiment. But when you move to the production step, you use slimmer images with fewer security issues. So what is the last layer? So we've seen at first the application code, the code that we write, the proprietary codes within the organization. Then, because we didn't want to reinvent the wheel, we've actually implemented a few packages. Thus, we're increasing the attack surface. We've been containerizing our application, again, adding more components and increasing our attack surface. And now we have the last layer. What could be that last layer? So the last layer is infrastructure as code. Infrastructure as code is an approach to manage data center server storage and networking infrastructure. It is meant to simplify large-scale configuration and management. So this is when you provision your resources through code instead of manual processes, because you want to make sure that your application is scalable and available. So this will make your code as your single source of truth, where you specify explicitly through code all the infrastructure specification in your config file. You'll have version control on all of your config files, and you can test and monitor your configuration. So IC is amazing, but the most common vulnerability organization face is cloud misconfiguration. And this refers to any glitches, gaps, or errors that could expose your environment to risks during cloud adoption. So you can view a few examples here. PlayStation Network has 77 million accounts hacked. Uber with 57 million also accounts breached. In their case, the AWS credits were stored on a public repo, so the attacker could scrap that public data and compromise this information. And FedEx breach also with 190,000 scanned docs. Cool. So let's have a look at a Terraform file here. So what do we have here? This is quite a big Terraform file, but this is just to demonstrate the sneak IC tests. So here, what do we have? I'm just gonna zoom this. So we're using the AWS provider in this specific example. We've defined an account password policy. We've defined a few other modules for VPC storage, CloudTrail, and we do have the Terraform files here. So let's open a terminal and do sneak IC test. So this is going to go through your Terraform files and let you know if there's any areas that you could improve and harden your infrastructure accordingly to a set of rules. So in our case, we can see that 0 critical, 3 highs, 9 medium, 7 low. Okay. If we have a look at the rules, we can see that there are a few around S3 buckets, CloudTrail, creds, security group. The one that we're interested in our case for this demo is the IAM password. Okay, so we're seeing here, IAM password should contain symbols, should contain lowercase, uppercase. Okay. Well, let's fix this. So I'm just going to remove this and rerun the sneak IC test. And we should see lower numbers. Should see a few difference. Yeah. So we did fix for medium issues here, which is a good start. Cool. But if you're wondering what are all those rules about, that's a good question. So if you actually click on one of them, you'll be redirected to our list of rules here, where you'd have a little bit more context around. So the rule, for example, the IAM password should contain uppercase with the definition of the issue, the impact, and how to resolve it. You'd have all the rules that you could apply to harden your infrastructure. And obviously, it's not only about IAM. You have a few services for AWS. And if you're not using AWS, but you're using Azure or GCP or Kubernetes, you also have those rules also to harden your infrastructure. And this is based this is checked against the CIS benchmark, which stands for the Center for Internet Security. And basically, this is guidelines to help you harden your infrastructure and make it a little bit more safer. Cool. So now we should have a better understanding of a modern application and new risk profile. So at the tip of the iceberg, you have the application code, which is 10 to 20% of your code base, which also potentially might have some security issues. But underneath this layer, we have the open source libraries, which is for 80 to 90% of the code base, where you might have 8% of vulnerabilities found in indirect dependencies. Then you're adding the containers layer, which also have the Linux packages, and we've seen some vulnerabilities around that. And the last one, the infrastructure as code with potentially misconfiguration within your environment. So it is important to have guardrails at each stages of your pipeline to spot vulnerabilities as your attack surface is getting bigger. So I've demonstrated at the coding stage that you could use tools like the CLI or the ID integration, and this could help you test and fix during that stage. So along with the way you're coding, and then patch will tell you if there's any security vulnerabilities within your packages, or also not only this, but also if I'm going back here, patch can tell you about what is going on within your code base. So here you can see that there's a few things around, for example, our hard-coded value. Here, because a patch did find some secrets that you've actually put it on your within your code base. For example, secret token here. Okay, CSRF protection, cookies, and other stuff. So yeah, you also have that layer not only for code security but also for code quality, and it's not only for the open source security. So you'd have this at that level of coding. Then when you push to the repo side, you also have the test fix monitor. So depending on your CI/CD pipeline implementation and the tools that integration that you're using, should it be GitHub Actions or Jenkins, Circle CI, you would have those endpoints where you could potentially have guardrails at this stage. Obviously on the production, also to test and fix and monitor on that side, and the registry for your packages and Docker images. So it's important to have that DevSecOps feedback loop because we want to empower developers to build applications securely within the entire development process. We don't want to have siloed team between security and engineering teams. It's important to have that constant feedback loop. Cool, so let's have a look at the defense in depth and some thorough practices and tech to consider. First of all, the open source software layers. So inventory your open source components. Don't give hackers more tools to expand their exploits. Leverage security tools. This is to improve your security postures for the components that you have within your code base. Embrace automation because you don't want to do manual tasks. Also, don't forget to include your open source software components in use within your security policy. And also you can start building SBOMs, which stands for the software bill of materials, that will help you having that visibility around software packages, contents, and license data. At the container level, don't run as root. You probably don't need it. Also, don't use privileged containers. You almost definitely don't need it. Drop capabilities, so dropping all and allow only what's needed. So if you don't need SSH or curl, for example, those kind of capabilities, just drop them. And yeah, deploy from known sources and pull from known registries only. You want to avoid typo squatting, the one that I've referenced at the beginning of this session, to avoid pulling malicious packages, for example. On the infrastructure as code level, secrets, use them, but make sure they're encrypted and have role-based access control applied. Security context to make sure that you don't run as root. Having a network policy with zero trust. And enforce and harden your infrastructure using the OPA, the Open Policy Agent, like Gatekeeper, to have policy controller for Kubernetes, for example, and tools from the Cloud Native Computing Foundations to help having that hardening infrastructure at that level. Cool. So before closing, I wanted to give you my top 5 tips. So tip number 1, adopt a DevSecOps approach. So this is the shift left approach, and it aims to detect security holes from day one in order to prevent security issues to begin with and to resolve them as quickly as possible if they do indeed arise. Tip number 2, address open source vulnerabilities. So we all love open source, the open source ecosystem, but while open source tools or components offer a great number of benefits, including cost efficiency, they also expose us to significant vulnerabilities sometimes. So when using OSS, ongoing monitoring for vulnerabilities, regularly updating and patching vulnerabilities as quickly as possible, this is therefore critical for your projects. Tip number 3, automate simple security tasks. It's virtually impossible to mitigate the endless number of vulnerabilities that exist using a manual approach. Automation is therefore critical, so all simple tasks should be automated in order to allow teams to focus on more challenging and interesting tasks. Tips number 4, be aware of your own assets. So visibility is the first step towards gaining insight into your organization's security states, as you can't secure what you haven't identified. So knowing precisely which assets make up your applications and software production infrastructure is key. And this goes back also to the SBOM discussions to have that visibility and insight. And the last tip is security training for developers. So developers are also responsible for pushing code into production. It's critical for them to receive training from the security team and to understand those security vulnerabilities and having a little bit more context around it. Which is a nice segue to a few resources that I want to share with you. So the first one is the Snyk security resources. So today the flavor of the session was JavaScript. So this is why I'm showing you the 10 npm security best practices and 10 React security best practices. But we do have also cheat sheets around Python, PHP, Ruby, Docker, and all the ecosystems. So really good read if you want to tackle this angle, security angle for your and make your applications more secure. Another good one is SnakeLearn. Strongly recommend to go on the SnakeLearn platform and start learning a bit more about all those vulnerabilities. So you have a lot of hands-on labs on a lot of vulnerabilities actually, not only on JavaScript but also the other ecosystems. The State of Open Source Security 2022. This is a joint effort between the Linux Foundation Research and Snyk. And this is showing you the current state of open source software security and how to improve your security posture, giving you interesting metrics and insights in this report. And we've also released last month the State of Cloud Security Report 2022. This is the same, but just to give you an idea of what is going on in the cloud security space and ecosystems, and what the security challenges that our organization are facing this year. Cool. So I'm Sonia Moisset. I'm a senior security advocate at Snyk. I'm passionate about DevSecOps, open source, and cloud security. I'm also doing a few things outside of Snyk, but I'm not going to bore you with this. You can reach out to me using Sonia Moisset on LinkedIn if you have any questions or feedback. But yeah, I just wanted to say thank you for coming today and watching this session. I hope that you've learned a few things. I hope that Patch and I did showcase a few interesting vulnerabilities, and you did learn a few things along the way. So yeah, I just wanted to say stay safe in your journey to cloud native application security, and thank you for attending this session today. Don't forget to subscribe to the Snyk channel. We do have a lot of interesting content other than the Stranger Danger. We do have a few interesting content around different topics. So yeah, don't hesitate to have a look at that. And yeah, see you next time, and take care. Bye everyone.